Okay, good afternoon, good morning, and good evening, ladies and gentlemen, wherever you are around the globe. You are welcome to the fourth edition of the Society of Information Science and Technology of Nigeria fourth webinar. This is one of the webinar series of webinar which we hold once in every 2 months. Today we have a very interesting topic to discuss. The title is Customer Churn in Banking, the role of machine learning and artificial intelligence in its prediction. And to help us do justice to this topic is Mr. James C. Enana. Mr. James C. Enana is a software consultant and an IT specialist based in the United States of America. Please let's give him a round of applause as he gives his webinar. Mr. James, please, you have the floor.
Okay, thank you so very much, Tunde. It's really an exciting time to be alive and to be opportune to give this talk. It is my prayer that at the end of this talk we will see the importance of artificial intelligence or machine learning in solving one of the I believe one very costly problem banks have. Banks anywhere, actually. Thank you so very much for having me. I want to thank the organizers, SISTN, Society for Information Science in Nigeria. Thank you for having me once again, Tuji, Mr. Tuji Apampa.
You are welcome.
Yes, and So basically, we're looking at customer churn in banking and the role of machine learning in AI. Machine learning in that customer churn issue, right? Of course, it's a given that nowadays, in recent times, there has been a lot of buzz about AI and artificial intelligence and so on and so forth in the area of government issues, in academia, and even in the industry. And so we find that these in these spheres of human endeavor, there has been a lot, actually dizzying rates of adoption of these technologies. Now, this has also ignited conversations as to what is real and what is hype, right? Well, is it really relevant? Its applicable use, its applicable use cases, even attendance privacy concerns. So, but today we are looking at, today's discussion is centered around the adoption of machine learning in providing a solution to I believe one of the most costly problems in banking. All right, so, right, of course, there have been applications of AI in core banking areas like fraud detection. Machine learning algorithms have been deployed, trained to recognize patterns, of fraudulent transactions and flag them for review. There is also the application of machine learning algorithms to assess risk level of potential borrowers in banks, analyzing a wide range of data points, to have more accurate risk assessments and leading to better, decision making. In the area of customer service, AI-powered chatbots have been deployed, to resolve inquiries 24 hours, 7 days a week, freeing up human customer service representatives to manage, other spheres of the banking process. In process automation, AI has also been deployed to automate some processes that are, unique to banks. For example, in loan approval or document management, these applications have been, these technology have been so deployed. Also, in personalized marketing strategies, customer behavior had been, profiled, and patterns have been identified and preferences, so that the bank can provide personalized marketing. All right. So same thing happens in the area of portfolio management. But this today we are looking at in more detail about the application of these AI machine learning interventions to predict reduction or to predict a customer churn, right? What is customer churn? Customer churn is a measurement, or a customer churn rate is a measurement that shows how many clients discontinue the service or an application or stop buying a product within a certain period. All right, this is a big problem for banks, especially, right? I remember some years ago, I was still in Nigeria then. I needed to pay my rent, okay? And it occasioned me to move a large, relatively large amount of money, okay, from my bank account, all right? And it was, yeah, and it was for my rent. But because I moved that money, and that's a very high percentage of my bank balance then for that particular account in a particular bank, the account manager, called me aside and began to query me, why are you moving this amount of money? What is going on? At first, I was taken aback because I believe it was my money, and these questions are not right. That's what I felt. Okay, so the man was trying to see, why do I have accounts in other places? Why am I moving money? All right, so I assured him that the money was meant for my rent. Okay, so his fears were allayed. Now that's his own heuristic method to see if I'm churning, to see if I'm leaving. Okay. There are instances again. I have another account person who refused to close my account, even when I asked him to. I asked him, please close this account. All right, but he didn't do that. He gave me excuses. All right, these are heuristic ways they have put in place, okay, to see if they can reduce or know why their customer is churning, why their customer is going away. All right, so now that's using human effort, heuristics, but that cannot be that is not sustainable. Customer churn now, rate. We're now proposing, okay, looking at how to use AI, all right, or machine learning to do some of these things. Okay, customer churn will cause banks to lose revenue and growth, right? Losing customers to the competition at a rate unmitigated it will sound a death knell to the financial health of the organization. Okay, when it's unmitigated, the customer rate increases the cost of doing business, right? Why? Because there have been studies that have shown that it is cheaper for you to retain an old customer than to acquire new ones. Okay, so existing customers leave for various reasons. Okay, so it is good for us to understand why and when a bank customer are likely to leave. This can lead to actions that will improve our customer retention and then help in our planning strategies for new ones. Okay, which is a positive double-edged sword, right? Banks can both reduce acquisition costs, that is acquiring new customers, and also increase revenue by retaining new customers, by retaining existing or old customers at the same time. So that's basically, in a nutshell, what customer churn is. It gives us the advantage, all right, when you reduce customer churn rate, where you provide remediation and methodologies. Okay, business employ know their customer better, right? Through this intervention we are proposing, we are looking at, all right, we spot opportunities for development, right, and boost revenue, provide or gain competitive advantage, and so on and so forth. So, want us to look at case studies of people, of organizations that had actually employed these AI methods in order to ameliorate or manage the rate at which customers leave their services, customers leave using their products. Amazon in 2018, wanted to improve customer retention and reduce the number of cancelled orders. That was the objective. All right. What they did was to provide or build a machine learning model that analyzed customer browsing and purchasing behavior, as well as customer feedback. The result is that it identified customers that are at risk of canceling orders. And then, because of that, they were able to provide personalized recommendation and incentives, which resulted in 25% reduction of cancellations and 15% increase in repeat purchases. The next organization is T-Mobile in 2019. All right, T-Mobile was losing a significant amount of customers to competitors, and they wanted to predict and then prevent that churn, those churn that time, right? So what they did was to build a machine learning model that analyzed customer data, including the patterns of the usage and billing history and customer service interactions. The result of that project was that they identified high-risk customers and offered, again, what they did was to offer personalized retention offers. The result is that 20%, the churn rate was reduced by 20%, and an increase of 5% was achieved in their customer lifetime value. A year later, the Bank of America, over here in the US, actually also wanted to improve customer satisfaction and reduce account closures. What they did, again, was to use machine learning algorithms and once again analyze customer transaction data, credit scores, online banking behavior. The result, customers that are at risk of losing their accounts were identified and they were offered targeted incentives. The result is that there was a reduction in account closures by 30% and a 25% increase in customer satisfaction. I just gave 3 examples. Well, there's another example. I called it the Nigerian insurance company. Yours truly was involved in this project. All right, in 2017. All right, this insurance company had a dated, quite an old software that we were actually is the company that I worked for that had provided that software, all right, and had used it for a while. So we were called in, all right, to modernize this software. One of the points of modernization is to introduce customer churn retention, all right, because we believe that then that will be good for, customer using AI, okay, machine learning. So that was done. We analyzed customer transaction data and online product consumption behavior. The result is that we were able to, for example, when a new customer comes into the bank, okay, the machine learning algo will predict if this person that just came in today, whether he will go away or whether he will renew his insurance business, his motor insurance in the next 12 months. So at onboarding, right, we're able to know if this new customer will stay or renew their business at the end of 12 months, right? So we find out that this feature, gives the bank organization superpowers what I just explained to you now feels like playing quote unquote God. Why? Because somebody just signed up for a service. And right from the day he signed up for the service, when you print out the report at the end of the day, we were able to know if this man will stay with us or will stay with the organization for the next 12 months. All right. Or if he's going to leave, he's going to leave in 4 months' time. Before that 4 months, we begin to present before him things that will make his life comfortable, things that will make him enjoy the service more, therefore discouraging him, from leaving the organization, from leaving the bank. So that's quite interesting. So what I want to do is to really go. I won't go into too much technical details because of our audience are diverse. All right, but then what I'm going to do is to try and explain how these things work. What's the mechanics? What works under the hood, right? Why? How does the magic, work? So here, of course, we know that customer churn problem project is a binary classification problem, right? Why? A binary classification has the outcome to be either true or false, okay? So whether the customer will leave or not, true or false, all right? Of course, there are machine learning algorithms that are suited, for this kind of challenge, okay? These algorithms includes logistic regression, decision trees, random forests, support vector machines, neural nets, gradient boosting machines, naive Bayes, and k-nearest neighbors machine learning algorithms. All right, so, but you see, I've just made a list, okay, of these kind of algos, but the selection of the appropriate algorithm is dependent on some factors. All right, factors like how much of the data available has missing values, how much missing values are inherent or are contained in the data available. Okay, another factor that will be considered is what is the quantity of data that is available, right? So some of these are the factors that one will look at, okay, for actually choosing the machine learning algorithm that you will employ for the project. For example, graded boosting machines. Random forests and decision trees actually handle missing values out of the box. Okay, they kind of preempt, all right, that this may be in the data, and then provide out of the box ways of handling those things. All right. So others like logistic regression, support vector machines, neural nets. Actually, if you're gonna use them, they require some data preprocessing steps in order to handle missing values. All right, like using imputation. Okay. So that's there. Then also that's for missing values. Then algorithms like logistic regression, naive Bayes, and nearest neighbors can be quite effective with less data. All right. So model prediction accuracy and generalization. That means the ability. Generation is the ability of the model generated, all right, to be able to predict from new data that he has not seen before. All right. This prediction improves, as you supply more data into the ML and machine learning model, the quantity of data will improve the accuracy, of those models, like the random forest, gradient boosting machines, neural nets, and support vector machines. Okay. So, having looked at these algorithms, okay, we have source of data. Data is always sourced from the bank's database in form of historical transaction data, customer service complaints, and customer demographic information, right? And then usually the thing is that we always try to split the data on which the models will be trained on, machine learning models will be trained on. Say maybe 75% of the data that is available can be, kept for such purposes, training purposes, while for testing purposes, 30% of the data can be provisioned. All right. So when these models spit out the prediction, right, we use a combination, right, of accuracy, precision, and recall, right, to gauge the performance of these models. May I say here that sometimes, aside from this, the machine learning algorithms can be deployed either as a singular, as on their own, right, or a combination, of their combination together to make predictions. F1 score is a balance between, is a metric that balances precision and recall. Okay. So that's just a diagram trying to explain what I have just what I've just explained, talked about, where you have your input data put into a machine learning, and then a model is built, okay, and then from that model, the model then does the prediction, and we now have whether the person can go forth out of their organization as a customer, or we retain that customer. Another magic powers that we find with the AI machine learning paradigm is the ability to explain the model. This is very important. What do I mean? The model is able to tell us, okay, that this particular bank customer will live in 6 months. This particular bank customer will live in a year. Okay? That is what that model is able to tell us. Okay? This customer, we have identified a customer. That's number one. Number two, we also have identified that he will live. Number three, we have also identified the time this person will live. Okay? That is what the model will do. But there is this technique also that we can use to know why. Why is he living? Is he living because he's a Gen Z? Is he living because his income is between this? Remember that when we were looking at the data source, some of the data that we collected is actually demographic data. We collected, transaction, historical transactions. We collected data as to customer service interactions. All right. So this shapely additive explanation called SHARP is a technique to explain, to investigate, to decompose what are those features. What are those, when we say features, that means properties, characteristics of that customer that actually impact, why the prediction went this way. Okay. So, all right. So maybe, for example, if the customer comes from a particular country or from a particular location in that country, all right, or his age, or his educational level, all right, sharp techniques, okay, will show us, okay, from these behavioral characteristics, what part of him is impacting his decision to live. So, for example, this is very important. For example, if it's the age that is making him live, for example, I said if it's Gen Z, therefore, for this particular product, what can we do to Gen Zs in our organization that will make them not to go away? Or if my organization, if for a particular banking product, all the people that we have that wouldn't go away are all first degree holders. Okay, so customers that are diploma holders, GED holders, we find them that they are leaving. So what can we do? That is exactly what this SAP Sharp technique shows. This diagram, for example, I just checked around to see which diagram I can use. Is a model explanation for a sample football match prediction, which of the team is which of the team has a tendency to have to win the man of the match award. Okay, so here, for example, okay, we have factors just like we have in banks that passes, goals scored, saves by the goalkeeper, free kicks, foul committed, corners, on target shots, goals scored, right? Ball possession, offsides, blocked shots, distance covered. These are metrics. These are features. These are characteristics of the team at play. So the pink side
in this last 10 seconds.
Okay, the pink side of this diagram is showing the contribution of all these characteristics of the team in predicting that this team has a 70%. You can see the figure, that middle figure, 0.70. Is saying that 70% chance this particular team has a 70% chance of winning the man of the match. Okay, right? The blue side is showing the characteristic of the team that is making bringing down the prediction, while the pink side is explaining why this team will win man of the match. In contributing to that prediction that this team has 70% chance, this person has 70% chance of leaving the organization, for example, goals scored, or educational, for example, educational qualification, right? Has the highest size. You can see the arrow, the way it's structured, right? It has the highest contribution of making this person to leave. Okay. In this example I am giving on the screen, goals scored is the most important attributes of the team that made them now have a 70% chance of winning the man of the match. The next contributory aspect is on target goals, 7. The next one is corners. So you can see the decomposition. This is an explanation of why or how the machine learning algorithm, right, predicted that this particular team has a 70% chance of winning. These are the kind of things we implement in order to give us superpowers input. I just mentioned Sharp and explained in details, but we have others like LIME, local interpretable model agnostic explanations, tells you which features are most influential, whether they pushed the prediction down or up. The thing with Sharp that we just explained is that Sharp will give you concrete weights, concrete percentages of those features. All right. While this will just show you a graph, okay, like your partial dependency plots shows how a feature affects the prediction. All right, on average. And then the other one is feature permutation importance. Presents what feature the model relied upon. You can see they are all similar, but what I just did was to arrange them, all these mentions, arrange them in the order of effectiveness and importance. All right, so that's what the whole thing is all about. All right, so you can see that another thing is that in concluding, one aspect of the project is that the project usually is exploratory in nature. There are no guarantees because you don't know what to meet. The data is new to you, is new to the algorithm, and so yes, we are trying to see the reason the customer will leave the organization, but then the results, those reasons we may not find. It's possible that it may not be in the data. It may be purely qualitative, all right? Then we have also the difficulty of time budgeting, the nature and integrity of data found after the fact. They make the natural iterative process to go out of scope because you see, depending on the data you are given, depending on the data that is available, right? You go, top down. You look, you review the data, you pre-process it, you fix missing values, you balance it if it's imbalanced, and all that. All that they take time, depending on the kind of tools that is being used. So basically, what I've just tried to do is to move quite quickly within 30 or 32 or 35 minutes, trying to explain how the magic works. All right. So basically, that's what I have. I do not know if we have questions.
Thank you very much, James, for your presentation. I think we have room for one or 3 or 4 questions. So Wiseman has opened the queue for questions. Please, let me see hands up. You have a question. I can't see any now. Okay. Just a moment, please.
Okay. No problem at all.
Yeah, I'm having a bit of technical issue on my end here.
Oh, okay.
So please bear with me here.
Sorry about that.
Dr. Ajibo, if you can handle the question from your end, please go ahead.
Okay, I can see one more person raising up his hand. That's Sunday Tumibi. So, Sunday, would you like to look first?
Okay. Thank you so much, Mr. James, for your presentation. I can see a lot of connection between, what you just said and data mining. Of course, data mining and machine learning, they work together, especially with the predictive modeling approach,
yes,
which is somehow related to supervised learning.
Okay.
So, but my own observation is this, that we are in a developing world, different from your own world over there. And of course, you know the way it is with our Gen Z here. Now, if we're looking at open source application, now, can you suggest any open source applications that maybe some of our own young entrepreneurs here can use for some of these things? Then maybe on a lighter mode, then can we give general advice on how we can, especially the young entrepreneurs, how they can retain customers? Just some general advice if you can. Thank you so much.
Okay, thank you so much, Dr. Tumibi. Your questions are on point. They're apt. What I would advise, let me take the last question first. What I would advise for young entrepreneurs, if they are true entrepreneurs, they have to have the never say die spirit. All right, no matter what, you keep trudging on because you see, an entrepreneur is visionary. Okay, and so nothing actually has the capacity to stop one whose idea, whose idea's time has come. All right. So I'm answering this question now. I will now answer that first one you asked. When I started this idea, I remember in this presentation, I made an example of actually servicing a Nigerian insurance company. This is in 2017. The tools we have now were not available, are not mature. Those days when we were handling those projects, when I was handling that project, I used all tools I use are open source. Right? I used the Jupyter notebooks on my laptop. And when I want to do my stuff, I do that data and I process some of the data from my laptop because of the limitations. But we were able to be successful. We have measured success even in that time. All right. So you can see that though we have other extremely mature tools right now on the Azure platform, Microsoft Azure platform, the cloud-based, service provision, right? But see, even now, when I'm making my presentation or when I'm doing my POC, POC, right? I still use those open source tools. They are free. Okay, I use Python for my programming, right? I use all these machine learning are provisioned already as Python additives, or Python libraries that you can add to your project and use them. Okay, so like I said, the project is exploratory in nature. Okay, so there are no guarantees, but an open mind should be used. Okay, that if you are going into this, you will just have to stick with it until you have success. All right. So the issue of tooling is not an excuse, right? Because those same open source tools I use, I am still using till date. They are free for anyone. Okay. Two is that I successfully implemented this idea as far back as 2017. All right. So there is really, really no excuse for any young one that is interested. So the issue is, are you interested? Are you visionary? Are you an entrepreneur? Do you have a never say die spirit? Success is yours. So that's my answer.
Thank you very much. Because of our time, we're running out of time. I want to call Dr. Tumibi, please. I'm sorry, apologies. I didn't know your title. That was why I just addressed you like that, the way we would do generally in the UK. Professor Olatokunsa, I can see your hands up. Professor Olatokun. Is he there? Okay, while we're waiting for Prof, my own question regarding this presentation is concerning the features, the parameters you used, especially during the project in Nigeria. We know that you've conducted that research and that product is out there. I want to ask, during that period, where did you get your data from with which you do your training? And after you've done the training, running that project for the app for like 1 year, did you go back to check the performance level of that application? I mean, do you consider what the software predicted? And at the end of 1 year, how many people actually were away from that product?
Yeah, okay.
Okay.
Thank you very much.
Hello, please, the presenter, James.
Yes, sir.
That was actually the question I wanted to ask, that what is the level of accuracy in the prediction that this machine learning thing you have presented to us? What's the level? Are there instances where the prediction, maybe people refuse to quit, and the algorithm has said this person will quit? Just give us an insight into the level of accuracy of the prediction that was experienced when it was applied. Thank you.
Okay. Yes, in the project, at least that one we the one I undertook with the insurance company, we had accuracies. We had my memory was about 75%. 75% accuracy. And in order to maintain, so I'm merging these two questions together, in order to maintain that level of efficiency, accuracy, of the model, that's what we call pipelining. Okay, you set up the pipeline such that the model will always be trained with new data. Secondly, if you see that particular project was peculiar in the sense that the company that I represented, right, is the sponsor or is the provider of the software, all right, that company was using to power their business. So, ab initio, I have as the software consultant that is in charge for my company of the product. being used by the insurance company for their services, for their insurance products, their back-end accounting products, and so on and so forth. That gave me a good ground because I have access to their data. I have access to their database. Now, having that access to the database, what I now did was to now implement a new feature. All right. So implementing that new feature of this AI feature, right? Data is not a problem to me. So all I needed to do was, like I said before, was to bring in accounting data, historical data, bring in the customer demographics that is in the already provisioned, and then do the job. Okay, so that's the way we did it. And then in order to maintain the level of efficiency, we make sure, all right, that we look at that the algorithm performance by supplying data, okay, for continuous training of the model so that the prediction will not degenerate. So basically, that's what it is.
Okay, thank you very much.
Yes.
Mr. Pampa is there. You have your hands raised up. Mr. Pampa. Oh.
Can you hear me, please?
Okay, we can hear you now. Yes. We can't hear you again if you are still there. Well, while we're waiting for him to sort himself out, I did ask the other time the features you actually look into, because I know Nigerian situation will be so peculiar that the features that will be attributed in Nigerian cases will be different from those ones abroad, like in the UK or in the US. Yeah, do you mind giving us insight into the kind of features you consider? Because I know we cannot have like a mortgage data for a customer in Nigeria. It's not that common. We cannot have a loan facility record for persons in Nigeria. It's not common.
Yes.
And these are part of the features that you will be using in foreign countries, if I'm right. So in Nigerian situation, what are the unique features that you actually use that makes it more accurate, like you get the 75%?
Yeah. For example, what you've said is correct. Okay, it's very extremely correct. It was a challenge. Okay, but then what we did was to make do. Okay, with what we have. For example, because it's an insurance outfit, it's actually one of the, right now, if I check their capitalization, they are actually one of the five biggest insurance company in Nigeria then, right now. Okay, so they have quite detailed, for example, know your customer KYC data. Okay, that was very helpful, right? KYC data, customer service interactions, okay, complaints, metrics, and also financial transaction data, okay, right? Because of that granular insurance data that insurance requires. For example, where do you live? Okay, what's your address? Your address is important. Okay. Do you have, for example, more than one car? Do you have more than one car with the organization? Do you have another cover from another insurance cover from other insurance companies? You know, some of these are some of these details. They may look simple, but you see, when you aggregate them and then allow the machine algos to sniff over them, results can be quite surprising. All right. So we may not have too much of what I call psychedelic, quote unquote, data points, all right, or features, but the simple ones that you and I know, demographics, address points, right, level of education, okay, all those basic data that actually you get from customers goes a long way. Goes a long way. And then, of course, what's the rate at which customers complain through the customer service, which is also a good one. That, of course, because of the software that we were managing already, we already have, it was a robust software product. I mean, the software they were using for their business, it was quite robust, okay? So some of these basic data points were what we relied on. And then we made sure we had a balanced data, all right? And then we were able to achieve that at least 75%, yeah, around that level of accuracy.
Thank you very much. I think with this, we've been able to come to the end of the program today. We thank you all for coming, for honoring the invite, and we hope to send you additional information. This will be uploaded to our YouTube channel. You can watch it there and refresh your mind about the concepts of AI in banking system. And also, we'll be bringing up-to-date news and information about the next webinar to you very soon. Thank you very much. And we want to thank our presenter. We want to say thank you very much. We appreciate you honoring the invite, and we look forward to having more of you as time goes on. Thank you very much.
So much. Thank you. Thank you for having me. I appreciate it.
You're welcome, sir. And thanks to everyone. And with this, we bring this to a close.